Okay, so if there is a background sounds or something like that, just ignore those because I am really recording at a peak time. So yeah, ambient noise will be there. Uh, this is a different kind of video I'm going to do. This is a review. This is a review of a AC power meter. This will be in-depth technical review. So if you do have experience in electronics or electrical engineering, maybe even like computer science engineering, you can kind of understand this. Um, Even a common layman who is really good with electricals will understand this. Right. So I do have two power meters. Actually, what happened was I got a meter, bought the meter from Amazon, and it died. It died. I'm pretty sure something really happened, like something really went wrong. And after that, I sent it to Amic, and they kind of sent me a new one, and that had some glitches to it. Like it is not always, but sometimes it glitches. And I just told them that, and they just sent me a new one. So I am having two power meters, and one I have sent it back. I do think I have to send one more. So whatever I have, I am showing in this video. I have bought it from my own money. So this is not at all a biased review. I'm saying all the things that went wrong with me. I'm pretty sure that it is my bad luck, and I got a poor power meter. I have seen many people use this in their projects, and they are really fine with this power meters. So I'm going to really access how the accuracy is and how this meter compares to uh, other power meters. I don't have any other power meters, but I do have a ways to measure power. So let's get started. First of all, when we want to measure something, we need to measure the consumption of energy of that appliance. So this is the power meter one actually measuring the consumption of power meter two. So power meter two is actually idle at this point. It is doing nothing. It is not hooked to anything. It's just powered on. And what it is doing is it is logging the power consumption of the other power meter. You can kind of see that you can ignore the kilowatt hour. It is cumulative. But what you have to see is 0.74 is the wattage which is used per unit of time, and you can kind of see there's really no time. It is just 0.74 watts, and you can see that it is reporting a current of 0.08 amps, which is absolutely correct. It is less count, so yes, it is absolutely correct for the counts. And there is also power factor, which is 0.04. Yeah, which is actually a little bit, you can say high, right? The power factor is not zero point 0.4, it is zero point 0.2 actually, point zero 0.02 actually, right? So let's go to the meter 2 while it is being read. You can see that it is just in the screen doing nothing actually. Okay, so let's measure the meter 1 with the meter 2. So measuring the power consumption of meter 2, so you can kind of see like the power factor measurement is a little bit different. That is all. Like the power factor into the current into the voltage, that is actually the power. So the power reading is basically changed only due to the power factor reading change. So any electrical engineer here in this would understand what I'm saying at this point. Okay, so meanwhile, the meter one is basically idle at this point because no load, it is just power on. Right, so I just measured the current of one of these meters. Actually, it is meter one actually. Uh, the current where like current was like 0.75 milliamps, and it is actually true RMS. So yeah, this is absolute RMS current. And if you want to check the accuracy of my multimeter, it is AN 8009. So that is any brand multimeter. I have verified with some other multimeters from Fluke and stuff like that. So it is pretty bang on. You can say calibration certificate was also included. So you can say the meter was kind of rounding up this point 0.07875 to 0.08. Right. So the meter is bang on. The meter one and meter two is really bang on. Right. So let's go ahead and do a meter testing. So this is like generic. You can say just how good is at reading watts. So this won't have power factor. You kind of know that the bulb is a resistive load. It might have a parasitic inductance and all that sort of jazz, but Moreover, it is just a resistive load. So let's just access it as a resistive load. So 42.4 watts. This is 42.2 watts, which is what I'm getting. Actually, this is a 40-watt bulb, and absolutely it is bang on the measurements. The power factor of this is 0.99. Actually, I don't think there is anything wrong with that. It is just 0.99. I don't think it will ever go on, and the amps is 0.18 amps, which is absolutely correct, multiplied by 239. So why 42 watts? Actually, when you think about it, these bulbs are only made for 230 volt. So you can kind of see that I am getting around 240 volt at this point. So I will get a little bit of more wattage, and the more the voltage is, the current actually increases more dramatically. So yeah, any electrical engineer will know, because the bulbs are like that. It is directly proportional, but the current increases a little bit more. The resistance is kind of not a direct resistance. It will change according to the temperature of the filament. Right. So now I do have a 100 watts bulb, and you can kind of see that it is literally bright. Uh, and the 104 watts is what is reading, and it is kind of also agreeing with the other one. It's basically double the current and double the watts basically. So yeah, you can see that this is pretty good. This measurement is pretty good. So this is the bulb actually. You can see the 100 watts. There. The other one actually it is kind of like scrubbed off. So yeah, pardon me for that. Here is the Humax LED, like 7-watt LED. You can say like this will have a power factor measurement, and you can kind of see like 0.99 is a power factor, which is being measured. But any electrical engineer will know that LED bulbs won't go up to that, even if there is a power factor correction. So it should be around 0.96 power factor also, but still it is quite good enough for that. And this is a 7-watt LED bulb, and kind of it did detect at least like 7.13 watts. Uh, if I am doing it correctly, it should be around 6.9 or 98 watts or something. Right. So this is Cisco LED, very reputable brand actually, and you can kind of see that the power factor is low for this, and you can kind of say like there's a little bit error in power factor. So yeah, the power measurement will be a little bit, I guess, biased, right? 8.59 watts is what is being read. I'm pretty sure it is just a bit less than 8.59 watts, but yeah, it is pretty good. So here is a Humax. I forgot to take the pictures of the Cisco, so sorry about that. Cisco is 9 watts LED, and the Humax is 7 watts, just for the sake. So let's go ahead and go with the measurements of the meter one. We did actually the measurements of meter two, so let's go ahead and do the meter one just for the comparison purposes. So first thing we can see is that the voltage actually did drift uh, while I was doing this, and you can kind of see that the both meters actually reported the exact same thing. If you think about the drifting of the voltage, 235 volt, which was 239 for the previous meter, so you can kind of see like 41.06 watts, and this is why I say, right, the voltage really depends on the wattage. Right. So 100 watts, you can kind of see that it again dropped like around 2 watts, and you can see that the voltage is also low here. So yeah, it actually explains why the voltage is like the wattage is low. Right. So both meters absolutely agrees. So let's go to the Humax LED, and you can kind of see that the Humax LED actually this time is producing 0.95 power factor and also 0.99 power factor. Actually, if I go to the next slide, you can kind of see like 0.96, 0.95, point. Yeah, it just changes. Like I think what is this doing is that this meter is much more accurate for power factor, so it is kind of like drifting across the ADC values. Like um, there should be a step, right? So it is stepping down and stepping up. It is like the noise, right? So it is just in the brain, I guess, right? So 6.85 watts is the power measured, and if you like look at the previous measurement, you kind of know that Um, this actually read like around 7 point something watts, 7.12 or something like that. So yeah, like the power actually is different, but as I have told you, like the power was actually different when we started this. Like it is only 6.96 ish, so you will be like getting around plus or minus like 5% of the uh, reading prompt. That is absolutely okay, because the spec sheet do say that it is it is not accurate to that extent. But as the wattage increases, the accuracy actually did increase, right? So let's go ahead and do the Cisca, and you can kind of see that the Cisca also does the same, where the voltage reading is a little bit down. Why I'm not considering the voltage at this point is that these power supplies are SMPS, right? So they shouldn't really depend on the voltage that much, but they do, right? Like I'm not saying they don't, they do, but they don't do that much as the GSI, like the normal incandescent bulbs. So that is that. 0.97 power factor, 8.29 watts, 0.04 amps, bang on, like bang on in the sense, like if you think about the error, it is absolutely perfect, like it is correct. So let's go ahead and do the current measurements. So first of all, the meter reading, like I showed you the first meter how much current it consumes. So this is second meter how much current it consumes. So it is 0.88 amps, 0.08 amps. So yeah, right. It is okay. Like it is okay. Why it is 0.08 amps? If you ask, it is having poor power factor. I am pretty sure this is a SMPS. There's an SMPS inside which is converting the power to 5 volt or something for the microcontroller to work. So let's go ahead and power on the LED bulb. So you can see that 92.4 milliamps is being consumed, and if you subtract the 80 milliamps from this, you kind of know that it is only like 12.4 milliamps, and 12.4 milliamps is what is being told by the meter, which is RMS, and you can kind of see that the amps doesn't agree with that, but what you get is the voltage, like the wattage is absolutely correct. This means that the power factor is a little bit wrong and the amps is a little bit wrong, but somehow both basically corrected to get same wattage. So if you really wanted a power meter, this will actually do best, because absolutely it will measure the wattage with the precision you want. But for the power factor and those kind of things, it is not absolutely correct, and the current part also it is not absolutely bang on. Like there is a little bit of difference. Okay, there can be also a difference which is imposed by the um, like a bulb interacting with the SMPS in this power meter. So there are a lot of things which can go different, right? So don't just think about like this meter is bad or anything. This is pretty okay for the price. And you can kind of see that this is a 40 watts bulb, and like 40 watts bulb, and it is saying 42 watts. And you can kind of see like 42 just reached out to around the same voltage. And what is it is saying that it is consuming around like zero point 0.2 amps. So you can kind of see like in the meter it is saying like not the multimeter, the meter is saying is 0.18 amps. If you kind of subtract the zero point 0.08 figure from this thing, you will get way lower than this. But yeah, like one thing you can guess is that there is some interactions with the SMBS thing. So yeah, right. This meter is pretty accurate actually. So 40 watts. It is. So here you can see the 100 watts, and at this point you can see that the error margin is really less. 0.443 is the current being measured in that, and you can see the meter also agrees with it, because zero point 0.8, if you subtract, you will kind of get almost the same result, but in not equal result. But as the current grows, the error is kind of same, right? So you kind of know like. That will basically improve the error factor, right? The how much error is in the measurement. as the measurement is higher. So let's go ahead and put a inductive load, just inductive load. This is a 35 watts air purifier. So you can kind of see that it is drawing around 0.16 amps, and the power factor is 0.93. You kind of know like these like air purifiers do have a combination of both inductive and also some SMBS and stuff like that. So it is not ideal inductive load, but you can say like combination load, ideal combination load, 0.93 power factor, and it is bang on with the watts. I'm just saying like it is bang on, right? So this meter is absolutely perfect. So let's go ahead and measure how the voltage is. So so many people actually do trust Fluke, right? I also trust Fluke. Like I do think those are the meters which are pretty calibrated. So you can kind of see that the 239.5 volt is being measured by the Fluke, and 235 volt is measured by the meter. So you can kind of see there is a little bit of difference, but is it significant? No, right? Like it won't even come close to 1% error. So you can kind of say like this is bang on. The spec is bang on. It is plus or minus 5%, right? So the plus or minus 5% is actually the specification of this meter. So this is pretty good, looking good, right? Okay, so let's go ahead and measure with the true RMS meter. You want, if you want to measure the voltage with the average responding meter, you can. But yeah, wherever whatever the true RMS says, it will be absolutely perfect. So you can kind of see that the true RMS and this basically agrees, right? The voltage is little bit different at this point, but you can kind of see that the true RMS and the fluke agrees. Uh, so why does the true RMS read little bit low actually? This every electrical engineer knows that the grid sine wave is not perfect. It has defects due to over the household appliances used by customers. Most of them are not having the perfect power factor. So what happens is the sinusoidal wave, the tip gets clipped. So this is why you kind of see the RMS, the true RMS is actually low, but if you do an average responding multimeter, you will get something which is higher, which is close enough. So, what do I think about this, right? What do I think? I think this meter is perfect. It is actually doing what it should do, and with minimal error while doing so. So if you want a really sensitive equipment, this is not what you have to buy, right? Like this is for folks who want to meter their electric scooter or something. I use it for electric scooter, but if they want to measure how much power they use, like for example, fridge, right? If they want to know how much power they use, they can just install this or something other than that, like you can just use it. I normally use it for testing the appliances, how is it good, and also for logging the power consumed by my scooter. So I guess this meter is pretty good for this purpose. And anyone who doesn't want, really bang on meter, right? Like to like millivolts and milliamps, and power factor to like 100 counts, right? Then you have to buy some kind of fluke or something like that if you really want that kind of accuracy, fluke power meter. But for that, it will cost like 34,000 or something like that. You are paying around 1,300 ish rupees. You get what you pay for. So absolutely go for it. zero point 0.5 watts power consumption is there. So yeah, think about it. If you are going to measure something really low, this ain't worth it. For example, if you want to measure a Raspberry Pi, don't measure Raspberry Pi with this. This will consume like half of what Raspberry Pi consumes, right? So yeah, something which is big. For that, this is good. 5 kilowatt meter. Absolutely go for it. I'm pretty positive that this meter will basically do everything it says. Uh, so what happened with my meters is basically I do think it is a some kind of a manufacturing defect actually. So yeah, the glitching stopped actually in the first meters. So I do think I don't know, like something was wrong with. the power up sequence or something like that. I'm kind of a computer science engineer, right? So yeah, I kind of know code, right? Sometimes things basically glitch out, and for the resetting, it has to wait until the capacitor is totally dead, right? So yeah, um, I guess this video was informative, and hopefully you will get a like you. Gave you the knowledge to knowledge the data to basically take an informed decision to whether to buy this product or not, right? If you want, you can just put these values in a spreadsheet, match it up, calculate the error and stuff like that. Just go for it, if you want. But for me, this is okay, perfect. Thanks for watching this video, and I will see you in a next review or some other video. It is random, right? So, bye bye.